want you to do today is go through and attempt these 3 problems, pause the video, and then when you're ready to go over them, play it again. So on number 1, the first thing that I would do is GCF factor out a 5 from each of these numbers. Remember, GCF factoring will save you a lot of time because it will shrink down your numbers. So I would GCF factor this out. Then this is a trinomial. So I'm going to do my factor diamond. On top, we do 5 times negative 72, oopsies, which gives me negative 360. On bottom, we put 31. What you're doing is going through and trying to find me 2 numbers that when you multiply them together they give you negative 360, and when you add them, they give you 31. Once you go through all the options, what will work is 40 and negative 9. The 40 and negative 9 is what we replace the 31 with. For right now, I'm going to ignore the 5 because we don't care about it, the 5 at GCF. I'm going to replace the 31 with 40n minus 9n minus 72. Now we have forced this problem to be a factor by grouping problem. So if I cut it in half and factor, I can pull out a 5n, and I will be left with n plus 8. And I can factor out a negative 9, and I will also be left with n plus 8. So my answer is 5n minus 9, which comes from the 2 parts that you GCF factor, and n plus 8. And then we can't forget this 5, so I'm going to bring it back down and put it in front of my answer. These next 2 are both some of your special patterns that we talked about. On number 2, I can GCF factor out a 3 first, and this will be m cubed minus 27, which makes it my difference of cubes pattern. So I'm going to write that out here for you in case you forgot it. This is one you will have to memorize for your test, so make sure that you're thinking about that. So if I have m cubed minus 27, that means my a value, if I cube root m cubed, is just m. And my b value, if you cube root 27, is just 3. And then I'm going to go ahead and fill that into my formula. So it's m minus 3 times m squared plus 3m plus 9. On number 3, this is my difference of squares pattern. Again, this is one you will have to have memorized. I cannot GCF this problem, but I do notice those are both perfect squares. So my a, if I square root 16a squared, is just 4a. And my b, if you square root 9, is just 3. And then we're just plugging this in. So it's 4a minus 3 times 4a plus 3. If you have any homework questions that you want to talk about together, you can. Otherwise, we will go over anything you want to talk about when I come back to class next time. Today what we're going to talk about is how you solve a quadratic equation. This is going to be extremely helpful as we move on in the chapter and we start talking about graphing and things like that. And so we're going to start talking about those today. When you're solving these equations, what will be important when we are graphing is that this will find me the x-intercepts of any graph, just like we did when we were graphing in previous chapters where we would set our equation equal to 0 and solve it. So when we solve them now, it's still going to find our x-intercepts of whatever graph you're talking about. So this is the skill we're working on so that you will be able to do this later. When we do this, you're going to have multiple ways to do that, and that's what we're going to go over first, is all the different ways that you can solve an equation when you're going. The first method is going to be to solve by factoring. I'm going to give you some steps here and then solve the problem that's off to the right. When you're solving by factoring, the first thing you want to do is to set your equation equal to 0. So I need to get this side of the equation to be a 0. I always try to keep my n squared positive, so I'm going to take the 3 and move it this way. But I'm going to minus 3 and minus 3. As I go through these, do feel free to pause the video to give yourself time to write stuff down, but I'm just going to keep talking. If you're solving by factoring, your next step is to factor whatever you have there. And this will not always be possible, but this is something that will help if you can. So since this is a trinomial, I'm going to put 1 times 10 on the top, a 7 on bottom. The numbers that multiply to 10 that add to 7 are 5 and 2. And so then I'm going to factor. So make sure that this makes sense. I would factor it on in your notes and then just check it with mine. And make sure you have the same answer. Your third and final step is to apply what we call the zero product property. Okay, what the zero product property says is that if two things are multiplied together, so if A times B, and they equal 0, then you know that either A equals 0 or B equals 0, because the only way we multiply to get 0 is if one of them is 0. How we apply that here is we will set both factors equal to 0 and solve. So I'm going to do n plus 2 equals 0, and I'm going to write n plus 5 equals 0. When we solve the first one, we would subtract 2, so n equals negative 2. So solve the second one, n equals negative 5. For these, you will typically have 2 answers when you're done. Not always, but usually. So this is the first method of 3 that you're going to use when you're solving equations. The second method is called solving by square rooting. And again, feel free to pause this as you go through, but I'm just going to keep talking about it. So if you need time to write anything down, take that now. Your second method only works when you have an ax squared and a c value, but no b value. It doesn't necessarily have to be equal to 0 right off the bat, but what's important is you have an a and a c, but no b. There's no bx in this problem. When you have just these two terms, you can absolutely factor it, but you don't have to. And so I'm going to show you this method because some people prefer it. First thing you want to do is isolate your ax squared term. And really you want to isolate just the x squared. So we are going to move that 8, but I'm trying to get this v squared alone. The way I do that here is I would divide by negative 8. When you do 128 divided by 8, you get 16. Then you're going to go through and do what the method really says. You're going to square root both sides. What's extremely important is you will need a plus or minus when you do this, and we're going to talk about why. But if I square root this 16, I'm going to have a 4, but I need to say that it is plus or minus 4, and the reason for that, if I plugged in 4 to this v squared, and I did 4 squared, that gives me 16. But if I plug in negative 4 and I square it, I also get 16. So there are 2 ways that I can square a number and get the answer of 16. So we have to show both of those here. But that's our final answer. The third and final method is one that is the only one of the 3 that always works. This one is typically the more difficult. The last method that I'm going to put in your toolbox for these is the quadratic formula. Your quadratic formula is actually the only of the methods that always works, so long as you have a quadratic equation. This does not work if your equation is raised to the 4th power, or the 5th power, or the 3rd power. Your degree has to be a 2 in order to use the quadratic equation, so that is extremely, extremely important. If you're going to use the quadratic formula, you do have to set your equation equal to 0 first, just like when you're factoring. So here I'll move that 10n over. So it's 12n squared minus 10n minus 15 equals 0. And then you're going to plug everything into your quadratic equation. You will have to have this memorized. You should have seen it before in Algebra 1. I will give you slightly more complicated ones than you saw back in Algebra 1, but this formula right here has to be memorized. When I plug into it, my b is negative 10, so when I plug into negative b, negative 10 is positive 10, plus or minus the square root of negative 10 squared minus 4 times 12 times negative 15, all over 2 times 12. When you're simplifying this, I would specifically first simplify your radicand, and then when that is done, simplify your fraction. Okay, so I will start inside the radical with that number under there. When I do, negative 10 squared, it's 100. And you're going to multiply everything at the back, and you should get 10 plus or minus the square root of 820 all over 24. And then you do need to go ahead and simplify that radical. Okay, so you need to find me the largest perfect square that goes into 820 that you can pull out. So take a second and do that. The largest one that does go in is 205, or sorry, it's 4 times 205. So when I simplify that, I'm going to have 10 plus or minus 2 root 205 all over 24. Okay, then we need to simplify the fraction. What helps some people is to split it apart. I'm going to write small because I'm going to run out of space. But this 24 really applies to each piece up here. So I'm going to separate it so that it's easier to see. So this is 10 over 24 plus or minus 2 root 205 over 24. When I simplify this first one then, 10 over 24, you can divide it 2 and 2, so it's 5 over 12 plus or minus root 205 over 12 also, because this 2 and 24 can simplify. Some people like to leave it together in one big fraction and just simplify it, and some people prefer to split it apart. I'm not going to be picky so long as you realize that these would be the same answer. So you could write it as 5 over 12 plus root 205 over 12, or you could write it as 5 plus or minus root 205 all over 112. What's important is that you recognize that those are the exact same thing. Okay, so these are your 3 different methods that you're allowed to use to do that. So for example, write this problem down. And I would pause the video and give it a try. And then I'm going to talk through it correctly with you. So feel free to unpause it as soon as you've had enough time to work with it. So this problem I cannot solve by square rooting because it has a b value. This 2a over here means that I can't just solve it by square rooting. So I am going to either factor a quadratic formula, which means I have to set it equal to 0. So I would move that 2a over by subtracting it. And personally, I always try to factor because I think factoring is easier than doing the quadratic formula. And so I'm going to try to find numbers that multiply to negative 15 and add to negative 2. Those numbers would be negative 5 and 3. So that means I can factor this, so I'm going to keep going. And when you factor by grouping, you get a plus 3 times a minus 5 equals 0. We are not done. We need to actually set these equal to 0 individually and apply that zero product property. Again, that zero product property tells me that if I have 2 numbers, which these are each just numbers, multiplied to equal 0, at least one of them has to be 0 because it's the only way we can multiply to 0. So with this one, I would get negative 3, and with the second one, I would get 5. You should again expect 2 answers every time you do these. So again, take a second and try to do this one, and then unpause it when you're ready to hear me talk about it. Okay, it is typically, like I said before, a good idea just to set it equal to 0 because 2 of our 3 methods you want it equal to 0. And then again, I always try to factor. So 4 times 14 gives me negative 56, and I'm adding to negative 14. And if you go through all your numbers there, this is not factorable. It is what we call prime because you can't break it down. And so we now have to go ahead and quadratic formula. So what I always do with these is I try to factor it, and if I can't, then I step into the quadratic formula. Okay, if I can, I just keep factoring because again, I think that's a little bit easier. So I'm going to label my A, B, and C, and then we go ahead and plug it in. Again, you will want this formula memorized. And like on the last one, or on the one we did as an example, I start with the radical. So I'm going to do 11 squared minus 4 times 4 times negative 14. Your calculator can probably handle typing all of that in. Oopsies. So this is negative 11 plus or minus the square root of 345 all over 8. And then I go through that radical and try to simplify it. You cannot leave it unsimplified if it is possible to simplify. But with this one, if you try to do it, 345, you cannot break down. So for this one, this actually is your answer. If you want to split it apart, you can. And the way you would do that is to write it like this by just breaking that 8 into both of them. You'll notice this doesn't simplify. 11 over 8 has nothing in common. And so does the root 345 over 8. So this is my final answer. Okay, go ahead and do the same thing with this one. We're just going to try multiple today because since I'm gone, I want you to see as many examples as possible. Again, pause it, but I'm going to go ahead and start talking about it. You can unpause it as soon as you're ready. If I go to factor, 3 times 7 is 21, adding to 2. And then you're going to think of all the ways to multiply to 21. So I can do 1 times 21 or 7 times 3. Neither of those will let me factor. So this is not factorable, which means now I'm going to have to quadratic formula just like on the last one. Okay, but again, I always try to factor first. Go ahead and plug it into the formula. You're going to get better at this as you go because you're going to have to memorize it. And again, I start with the radical. So 2 squared minus 4 times 3 times 7 is negative 80. And this is part of why on your October spiral review last week that I had you actually simplify these radicals. So when I go to simplify the square root of 80, I'll write it up top in case you need to see more work. This negative, you should remember, pulls out as an I. And then 80, the largest perfect square that goes into 80 is 16. So this is going to be 4i, when you square that 16, root 5. So I'm going to fill that in. What this means for us, this is going to be really important when we get to a graph. We have an imaginary answer for our solution. So like I said before, it finds your x-intercepts. In cases like this, you're actually not going to have an x-intercept because it has an I, and we can't graph an I yet. We are still going to simplify it. So it's negative 2 over 6 plus or minus 4i root 5 over 6, and then I'm going to see what I can simplify. Well, 2 and 6 gives me negative 1/3. The 4 and 6 gives me 2i root 5. Oopsies. Root 5 over 3. So this would be my final answer. Again, you can write it as 1 fraction or 2. And then you would be done. Okay, go ahead and write this one out if you need extra practice. If you do not need this one, feel free to just skip ahead in the video. I will talk about it just to make sure you know how to do it in the event we need this. But you can absolutely just skip ahead of this one in the examples to the next ones after it if you don't need this one. When I move everything over to the same side, I'm going to add 4, so this is negative 26n plus 35 equals 0. 3 times 35 gives me 105, and adding to negative 26, this one will be factorable, I believe, if I remember correctly. Okay. Your pair, and I do remember correctly, is negative 21 and negative 5. So this is another good example of how you would do it if you were solving by factoring, because now I can actually keep going and factor this problem. So I'm going to do 3n squared minus 21n minus 5n plus 35. And I would have 3n that I can pull out here, and negative 5 to give me 3n minus 5 times n minus 7. And then again, we apply our zero product property. On this one on the right, you get n equals 7. On the one on the left, you add 5, and 3n equals 5. You do have to divide that. So here we get a fraction for one of our answers, but that's okay. That one is completely done. Okay. Moving on, we're going to talk a little bit about something we did last chapter, but that you needed this skill to be able to keep going. So this one is a radical equation that you already learned how to solve, and now we're going to see how you can solve a different type that I didn't give you before. So if you remember, when we solve radical equations, the first thing you do is isolate this radical, which it's already isolated, and then you go ahead and square both sides. Oopsies. On the left, the radical and the squared cancel, so I just have 54 minus 3x. But it now equals, I have to leave this as x squared. So now we have a quadratic equation that you're going to use the tools you learned today to be able to solve. I'm going to set it equal to 0 first. I always move everything to my x squared, so I'm going to add 3x, oopsies, and subtract 54. Just to keep my x squared positive. It usually makes the problems much easier to do. And we're going to see if we can find a pair of numbers that multiply to negative 54 and add to 3. So take a second and try to find that. Your answer should be 9 and negative 6. So now we can go ahead and factor. This is now the exact same problem we just did, where we were factoring. It just started as a radical. And then again, you're going to set x minus 6 equal to 0, x plus 9 equal to 0, and x is 6, and x is negative 9. The second important part here, though, that's different, besides that we turned our radical equation into a quadratic, is now we have to check our answers. When we did this before, you were not allowed to just keep those answers because they weren't both right. When we check, you're just going to plug in each one at a time. So 54 minus 3 times 6, and you're seeing if that equals 6. And you're going to do square root of 54 minus 3 times negative 9, and seeing if that equals negative 9. When you do that here, you get square root of 36 equals 6, which is true, so that's good. When I do the second one, I get square root of 81 equals negative 9, which is not true. So this negative 9 we have to cross off, and the only answer is 6. This is going to be the last example we do here, so go ahead and write it down. There is a trick to this one, but it is similar to before, so I want you to think about it for a second and see what you would do first. The first thing we want to do, remember, is isolate this radical. So I need to move this negative m by adding it to the other side. So square root of 7m minus 54 equals m minus 6. And then like before, we're going to square both sides, but what's different is you need to remember you are squaring a binomial on that left side right now. So 7m minus 54, you're going to have to write this twice and FOIL. And you should get m squared minus 12m plus 36 as your answer. Then we need to set it equal to 0. Again, I move everything to be with my m squared, so I'm going to move the 7m and the 54. So it's going to be m squared minus 19m. When you do negative 12 minus 7, and when I add the 54 to the 36, I get 90. So go ahead and factor that for me. This is what you should get once you factored it, but feel free to slow the video down or pause it to make sure you got all that. And m minus 9 equals 0, m minus 10 equals 0, and m is 10 and 9. Again, you do have to check it. You can check it at any point before you squared both sides. So say I want to check it after I moved that m. I would do it here, so 7 times 9 minus 54 squared, that should equal 9 minus 6. And I'm also going to check 7 times 10 minus 54, and that should equal 10 minus 6. When you do the left side, you get square root of 9 equals 3, and that does check out. When you do the other one, you get square root of 16 equals 10 minus 6 or 4, and that also checks out. So both of these are answers. Sometimes you'll have both of them work, sometimes neither. You just have to check to actually find out.